Almost everyone has amazed at the night sky's vastness and wondered about the secrets of the final frontier. Nevertheless, certain erroneous beliefs about the world around us have been spread by films, television shows, and literature. Therefore, let's use science to dispel 10 of the most widespread fallacies and false beliefs about our universe. Number 10. No longer present and dead. Many of the stars we see at night are no longer present and dead. On Earth, it takes a long time for the light from a far-off or dying sun to reach us. Therefore, a large portion of the 6,000 stars we can see at night must be extinct, burned up, and dark. Right. Actually, not at all. All 6,000 visible stars are probably still shining brightly and are in excellent condition. Less than 1,000 light-years separate all of the stars that can be seen from Earth, which is rather close for stars. Therefore, it is extremely unlikely that any star we see has passed away in the time it takes for its light to reach us, 186,000 miles per second, 300,000 kilometers per second. Number 9. The universe has no end. There is no question that the universe is vast, but it is also limited. It does come to a close. The Milky Way, our galaxy, alone contains more than 200 billion stars. Additionally, the cosmos is thought to contain 2 trillion galaxies. Yet it is still quantifiable. The radius of the cosmos is about 47 billion light-years in all directions from Earth. Additionally, the diameter is 94 billion light-years long from end to end. What lurks beyond those planets and stars on the edge of the universe is a more mind-boggling question. Number 8. Like enormous vacuums, black holes absorb everything. Black holes are not terrifying cosmic tornadoes that devour everything in their path like we've seen in movies. Black holes also don't go out looking for planets to eat in order to live, develop, and prosper. Massive stars that run out of fuel and start to die and collapse create black holes. During that collapse, the star gets denser and denser, increasing its gravity as a result. This increased gravity then starts to pull on nearby objects, including light. Yes, that gravity might draw planets, moons, and other stars toward the event horizon, the black hole's furthest boundary. But that black hole's gravity is merely ordinary gravity with more of it. For instance, the gravity from a black hole generated by the death, collapse, and creation of a star 10 times as massive as our Sun would be equal to the mass of that star. Number 7. Dark matter is negative and harmful. The Expanse, Star Trek, Futurama, 10 Files, and even Scooby-Doo, to mention a few, have all featured dark matter as a story element. But is it truly nasty, devious, and sinister? Obviously not. Dark matter makes up 27% of the universe's matter while being completely invisible and never having been seen or detected. In essence, it is the matter found in the spaces between suns and galaxies. The majority of scientists think that this intangible substance is composed of WIMPs, or weakly interacting massive particles, which have masses significantly denser than protons. However, because of how weakly they react with other substances, they are hard to find, i.e., dark. Number 6. Rare Earth-like planets. 24 planets found by scientists that are even better for life than Earth at only 4 light-years away. Proxima Centauri b is the nearest planet to us that resembles Earth and may even be habitable. And even with our current technology, it would still take 60,000 years or more to get there. But let's distinguish between the possibility of other worlds like Earth and the closeness of another habitable planet. According to astronomers, the Milky Way galaxy alone has 300 million to 6 billion potential Earths. Additionally, there may be 76 sextillion stars like our Sun and their circling livable planets in the universe's 10 trillion galaxies. Number 5. When we achieve speed of light travel, we will be able to fly through the galaxies. Why it is not a good idea to travel at the speed of light. Hyperdrives, warp drives, and other futuristic technology are frequently used in fiction to travel quickly between galaxies and planets. However, light speed or even close to light speed travel is not possible in the real world. In his theory of relativity, Einstein explained that as an object's speed increases, its mass increases and it becomes heavier. As a result, any object that accelerates to a speed even near to that of light would begin to have infinite mass or energy. And that simply cannot occur. In the lab, a photon, which has no mass or weight, has been accelerated to 99% the speed of light. However, the energy needed to move even 1 gram of anything would be infinite. The conclusion is that nothing that has mass can ever travel at the speed of light. Number 4. An explosion caused the Big Bang, most likely not what you think it is. The Big Bang, there was a tremendous explosion that created the cosmos and everything in it. The name of the theory, the Big Bang Theory, says it all. Cosmologists, however, are always working to explain that. The universe was believed to have started 13.8 billion years ago when a little, dense ball of substance suddenly went explosion. But did anything actually explode or blow up? The general view is that a quick expansion rather than a bomb detonating caused everything to begin. And it was space, not the things in our universe, that experienced a rapid expansion, faster than the speed of light. Despite the fact that everything is still in the same location as it was 13.8 billion years ago, the distance between the items is expanding. This explains why there isn't a void at the center of our universe, which would be there if everything were to be blasted away from a single place in the universe with an explosion, a bang. Number 3. Aliens might visit Earth. How developed would alien life have to be before it could contact Earth? Especially in light of the numerous UFO encounters that occur in North America every year, that seems feasible. And one may logically believe that extraterrestrial visitation to Earth are a possibility if only a small percentage of those encounters were real. However, let's recalculate those enormous figures. There is no question that there is extraterrestrial life, some of it developing, intelligent, and possibly technologically advanced, given that 75 sextillion 909 quintillion stars in the universe have habitable planets orbiting them. The question is, could those advanced beings travel to Earth? The Milky Way, the only galaxy in our vicinity, is 100,000 light-years across, and even extraterrestrials must deal with the practical issues of space travel, food, fuel, radiation, etc. The Voyager spacecraft is currently the fastest man-made object in space, moving at a blazing 11 miles per second. Voyager would take 72,999 years to get at the nearest star even at that speed. How could any being possibly survive a journey that could take millions of years, given all the dangers along the way? Similar to Neil deGrasse Tyson's statement that, you want to be alive at the end of your experiment, not dead, so, absolutely, life exists elsewhere. But it's not coming this way. Number 2. No one can hear you scream in space. Finding a scream in space. No one can hear you scream in space, as the adage goes. That assertion makes sense given that space is a vacuum and that there is nothing for sound waves to pass through. You shouldn't even be able to scream. It depends on where you are in space, according to NASA researchers. Researchers heard a variety of unsettling sounds while listening in on a massive gas-rich black hole close to the Perseus cluster, a galaxy 250 million light-years away. So go ahead and scream if you want to. In a region of space that is filled with dense gases, plasma, and other particles, you won't be wasting your breath. Number 1. The sun is a massive fireball. Well, actually, it's more like an endless series of hydrogen bomb blasts. The hydrogen atoms in the core of the sun slam into helium atoms and fuse together. That fusion, or that nuclear reaction, releases large amounts of energy, just like a nuclear power plant. And those reactions have been powering the sun for 4 billion years. Luckily for Earth, the density and gravity of the sun are so great that it keeps everything together and prevents itself from blowing up.